Welcome back, all of you. Let us start with the next paper. Next paper is by Mr. Srinivaslu Kunturu with paper ID 37, titled Comparative Analysis on Surface Roughness, Material Removal Rate, and Tool Wear Rate for Aluminum Alloy 6082 and H13 Steel in EDM using Taguchi's method. Sir, please.
Good morning. Good morning to one and all. This is Srinivasulu. So I'm happy to share the PPT in this ICDF conference. That paper title is Comparative Analysis on Surface Roughness, Material Removal Rate, Tool Wear Rate for Aluminum Alloy 6082 and H13 Steel in EDM using Taguchi methodology. So the outline of the presentation, introduction of the topic, then application, abstract, materials and methods, experimental procedure, results and discussion, conclusion. Then come to the introduction. So aluminum material, so the aluminum alloy 6082 is a medium strength heat treatable alloy with high corrosion resistance. This is the main important point. It is often used for high stress application such as bridges, cranes and stresses. Present used in the aluminum alloys is more applications. Then coming to the properties, the good properties, the high strength, corrosion resistance is more, and weldability and good machinability. These are the main properties of the aluminum alloy. Then coming to the steel, the hard tool steel that is used for the making parts that withstand the high temperature and abrasive. It is used for the variety of applications includes in the hard work tools, extrusion tools, and plastic models. The main properties of the hard steels, high hardness, toughness, resistance to the thermal fatigue cracks. These are the some application for the alloy and steels. So constructions present mostly used in the aluminum constructions, but present in olden days compared to this one, alloys also increases the strength of the material. That's why mostly used in the aluminum because of the corrosion resistance. So coming to the abstract, so in this paper is for the EDM, electro dischargeable missions. So in this mission is mostly is to convert the heat energy. So maximum 9,000 to 12,000 degrees Celsius. Since the high thermal energy, metals melt and evaporated. So in present this paper, the comparative analysis of the machining of the aluminum alloy and steel. So the EDM mission using for mission SN35S, and the electrode is a electrolytic copper electrode is for the cutting material for this experiment. So then the both operational elements are same for the two materials for aluminum as well as steel. So there is a voltage, current, pulse on time, pulse off time. These are the common for both the experiments. Then coming to the optimal parameters are surface roughness, tool wear rate, and material removal rate. So by using this analysis, the Taguchi method is the using for basic to optimize the solutions. So there is the first one, aluminum alloy is the one block. Another one is the die steel is another one. This is the material is the copper electrodes used for this one cutting material. So these are the different properties about the aluminum alloys and the die steel. Then this is the methodology, means this is a structure for design for the Taguchi. So the parameters are discharge, means current, voltage, pulse on time, pulse off time. These are the parameters, and there are 4 stages. Stage 1, stage 2, stage 3. So take the different values. The total array is the L16 array. So total 16 iterations, means 16 trials to conduct the experiment. So this is a experimental setup for this operation. Then observe these results and is coming to the results and discussion. So these are the total 16 experiments with 16 trials. So in this first one is the current, voltage, pulse on time and pulse off time. So based on the experiment results, so analysis by using Taguchi analysis by using Minitab software. So the aluminum alloys, metal removal, tool wear and surface roughness values, and as well as steel also take the metal removal rate, tool wear rate and surface roughness values. So coming to the graph, this is for aluminum alloys. So in this mean effective class for the material removal rate. So observe the first graph, means first one is this one. So current versus S by N signal to noise ratio. In this, the 30 is the influence parameters. Then coming to the voltage, in voltage is 40 is the influence parameter. Coming to the pulse on time, so is 9 is the influence parameter, and pulse off time and is also 9 is the uh, optimal parameter. So compare this one. So the current is followed by the pulse off time, then followed by the pulse on time, then voltage. So the mean effective plots for the tool wear and surface roughness values. In tool wear is the voltage is the main influence parameter. Coming to the surface roughness is the pulse on time is the influence parameters. So then followed by the current. So by using the ANOVA analysis, so here observe this one, the current is the most influence parameter. So coming to the tool wear rate, so here the voltage is the most influence parameter. Then surface roughness, so the most influence parameter is the pulse on time. So based on the analysis, the results is the mostly mean best values for the material removal rate and tool wear and surface roughness values is this is the so this one is the this. So, then steel. Coming to the steels. So in the steels also, so this is influence parameter is the current is the most influence parameters at the material removal rate. So compared to other parameters means voltage turn means pulse on time and pulse off time. Then coming to the tool wear rate here, this current is the most influence parameter compared to the aluminum. So then coming to the surface roughness, here also current is the most influence parameters. In the aluminum is the pulse on time is the most influence parameters. So the best optimal values for the aluminum alloy is material removal rate is 99.2 and tool wear is 0.02 and surface roughness 11.6. Then coming to the conclusion, so based on these two experiments, the aluminum compared to aluminum is the one area means one parameter is good for the uh, steels. So remaining is better. Aluminum alloy is the better. And for example, in surface finishing area, so aluminum is the not good for experimental based on the experimental results. So remaining conditions, aluminum is the good for the parameters.
Thank you, sir. Thank you for the presentation.
Mr. Srinivaslu, thank you for the presentation. I have one basic question. Why did you combine aluminum with die steel? Is there any reason why
So-
both the results are combined?
So actually, this is the one part of that research. So remaining research is so only that's why you present the only.
No, is there any correlation between these two materials in terms of tensiles and nowhere they are related? Is there any reason you have combined the results?
Combined research means, for example, nowadays mostly used in the aluminum alloys for the different constructions fields. So the properties of this both are the similar properties. So that's why aluminum then compared to steels, mostly in place of steels used for the aluminum. That's why.
But die steel it cannot replace aluminum. How it can replace die steel? What is your objective? It is not clear. Why did you combine? Okay. What is the R square value in ANOVA? Have you calculated R square? Where is the R square? Where is R square?
In this table is not mentioned the aspects of this.
So how much R square value you got? Or any P value you got?
Sir, everything is when the tables is not mentioned this series.
Which are the significant parameters? And where is signal to, you said Taguchi you have used. Where is SN ratio?
First table already mentioned this was when decibels.
Where is signal to noise ratio?
The graphs only mention signal to noise.
Okay, because it is not completely presented, whatever work is there. And it is a wire EDM or normal EDM?
Normal reading.
Okay. What was the electrolyte used for both aluminum? Is it same or is it
Both are same.
same?
So this is a only one tool used for this first paper. So remaining papers are there. There is a different cutting tools are used when complete the.
What was the geometry you were machining there? Using EDM, what was the geometry or material geometry where you are removing?
So a small circular, take the materials for using magnetic parts in that circular and five
So
circles.
nowhere you have shown. No? So have you fixed the volume like this much volume? I'll remove.
Yes, sir.
What was the volume?
But the convention, so that circular for take that one.
Everything is not mentioned means then what you are presenting in the paper? Is it mentioned in the paper?
Thank you, sir.
Thank you.
Thank you, sir. Yeah, 1 minute. Question from audience? No questions? Okay, thanks.
Thank you, sir. Next paper is by DRS Narsingh Rao, sir, with paper ID 93, titled Enhancement of Mechanical Properties of Teak Wood. Sir, please.
My name is Narsingh Rao, DRS Narsingh Rao. I'm working in VJIT as an assistant professor in mechanical department. So, this is my and my topic is enhancement of mechanical properties of teak wood. So it is a part of my PhD work. This is a very little part. So that's what I'm presenting here. So my abstract is, so starting why I have chosen this one, because of we are using plenty of wood. Okay, we are using plenty of iron materials. Can we replace with the wood? Can we replace with the wood? Yes, it is possible. Now, how it is possible? We have to strengthen the material and we have to make them hard. So this is we have demonstrated in this work to take wood by modifying internal structures. First, we have to check the internal structures, what we can do, and then eliminating the defects. Okay, step by step. So I have taken two process, that is thermochemical process and thermomechanical process. Two processes we have taken. Now preliminary work from the so what it does, it makes bedrock for further advances for improving mechanical properties to improve heavy duty structures. So let us come to the introduction. So here what we are doing is, I have taken three that one. So background of wood application first, then problems with metals, resource depletion and environmental impact, then advantages of wood. Now, what are the advantages of wood? We are taking. So here, background of wood applications. We know the plenty of applications of wood here. So that is, we are making some doors, everything. We know this one. So let us come to the next. So what happens if we are using metal? What happens if we are using the metal making? So by using metals ores, what we are doing is, here we can, so we know greenhouse effect is there. So carbon dioxide emission is there. We are wasting the store. Okay, we are wasting the store and we are taking toxic materials and we are taking global warming here. So because of using of metals. So we have to overcome this one using wood. So here, so what are the advantages of wood? We know very well. So it is a renewable resource. Okay, it is a strong building materials. We can use as a fuels also. and it is sustainable, it is energy efficient, and it is a very durable. Let us come to this now. Now, what is the composition of wood? We come to here. Now here, from the nature, we are getting a wood from the nature. Now, it is consist of hemicellulose, cellulose, and lignin. Now let us come to the microstructure of wood. So it is like porous material. Porous is there. Now let us come to that one. The green structures we are seeing, no? So that is nothing but cellulose. Okay, just like tube structures. That is nothing but cellulose. Now in that cellulose, there is two small is there, no? Small, chinna chinna unnai kada. That is hemicellulose. Now this hemicellulose is bonded with lignin. This is bonded with lignin. Lignin means it's a just like gum-like material, okay, which is bonding between the hemicellulose. Okay, so now what we can do, now here we can remove the lignin. We can remove the lignin here. Okay, now there is a process that is said to be a thermochemical process. Now here, what we see here. So what I am doing, so natural wood, we are taking a natural wood and I'm making a chemical treatment, and from there I'm taking out or 80% of material, lignin, hemicellulose I'm taking out, and then it increases the strength. How increases strength? Now, so here I have taken chemical treatment, mechanical treatment, and I have used some tests, few initial tests I have taken. So let us come to the chemical treatment. So here I have taken a wood, some cutted pieces. The area of this one is 40 by 40. I have taken, okay, 40 mm by 40 mm. So 100 mm size I am taking, means almost all 10 centimeters I have taken. Now what I did is I kept in a solution, that is sodium hydroxide, sodium sulfate in the distilled water. So what I did, I have taken this 2.5 moles gram of that sodium hydroxide and 0.4 moles of sodium sulfate. I kept this one for certain period of time. Okay, I have chosen for 5 hours, 17 hours, and 24 hours. 3 stages I have taken. So I'll say this is a thermochemical treatment for 1, thermochemical treatment 2, and thermochemical treatment 3. I have taken a 3 stages. Now this whole setup is kept in the furnace at 100 degrees Celsius. I have taken then heat chasam. So after that, the wood block placed several intervals. This is 5 hours, 17 hours, and 24 hours. Then what I did is, after that, I have used thermomechanical treatment. So here, I have taken that wood and I kept at 100 degrees Celsius for 2 hours, and I have used this UTM at the UTM. Okay, I have pressed this one for 2 hours at the load of 5 kilonewtons. That is 5 megapascal. Okay, for 2 hours consistently. Okay, so this is the we have ordered this one. This is the setup for making 100 degrees Celsius. అంటే 100 degrees లో పెట్టి దాన్ని హీట్ చేయాలి. డైరెక్ట్గా హీట్ చేస్తే కుదరదు, నాట్ పాసిబుల్. సో వాట్ వీ డిడ్, వీ హ్యావ్ టేకన్ దిస్ వన్. సో దీని ఏమంటున్నాం, దిస్ ఇస్ మైకా బ్యాండ్ హీటర్. ఓకే, అటాచ్ టు ద సప్లై థర్మల్ ఎనర్జీ పెట్టడానికి. సో ఇట్ ఈస్ కనెక్టెడ్ విత్ ద ఎలక్ట్రిసిటీ. ఒక చిన్న రియోస్టాట్ పెట్టాం ఫర్ సెటప్. ఓకే, నా వాట్ వీ డిడ్ ఈస్ వీ హ్యావ్ అప్లైడ్ ఎ లోడ్. Okay, this is the raw material we have taken. After applying a load, this is compressed something like this. Okay, then these samples we have tested. Okay, we know ICIFMEDE impact test. Every mechanical people know this one. So what we did for ICIFMEDE impact test, I have cut that material for 10 by 10. Okay, 10 by 10 is 100 mm cut chesam. So I have taken I know this formula, I is equal to K by A. Now, and also after ICIFMEDE impact test, we have taken a hardness test, vinyl hardness test, we know. Okay, now we know the formula HB is equal to 2P by pi D, D minus underscore D square minus small d square, where D is a indenter, we know, and after indenting, whole vartundi, there is a small d, we have to calculate in the micrometer. Now, these are the results I have got. So stiffness factor and the toughness we have got in the ICIFMEDE impact test. So stiffness factor, that is a NW, means new wood. దానికి ఏం టెస్ట్ చేయలేదు, డైరెక్ట్లీ వీ హ్యావ్ డిడ్. ఆఫ్టర్ టెస్టింగ్ For 5 hours, we have taken 3 wood. That is 5 hours for 17 hours and 24 hours. So we have got that values 0.02, 0.04 and 0.05. And for brittle hardness test, I have got 13.69, 14.99 and 2257 and 2357. That is brittle hardness number. Okay, so these are the graphs. So by seeing this graph, we can say we have improved the hardness and toughness of the material. Okay, so these are the conclusions. So teakwood samples are taken from 2.5 moles, and teakwood samples are subjected to thermochemical treatment at 100 degrees Celsius. And we have applied at UTM for 5 kilonewtons at 2 hours at 100 degrees Celsius. After that, we have got so and so values. So 3.69, 4.99, 2.57, and 23.75 kgf per millimeter square. After that, we have taken these values from in the ISOD impact test. So this is the future work. So what I am going to do in the future. So next my work is here. We have to take the microstructural tests. Okay, so I have to do 9 tests at least here. That is an anisotropic test, ballistic energy test, scratch test. Okay, hardness modulus test, and scanning electronic microscopic test. Okay, mechanical modeling test. All these tests we have to perform here. Any queries, please?
Thank you, sir. Thank you for your presentation. Please.
Sure. Thank you for the presentation.
Sir.
So wood is a very old one, right? Later on, the metals replaced with the wood. What is your objective? It's not clear for me. What is the objective of moving back to again for wood?
Sir, replacing of metals, making using of wood, sir.
The wood
That is
means directly you are cutting the tree, right? So, which is also not a green.
We can
initiative.
farming, no, sir. We can farm and we can use. So main initiative is metal use చేస్తే మనకి పొల్యూషన్ 8% ఆఫ్ పొల్యూషన్ ఉంటుంది సార్ ఇన్ ద వరల్డ్. సో వీ కెన్ రెడ్యూస్ దట్ వన్. గ్రీన్ హౌస్ ఎఫెక్ట్ అవన్నీ ఉంటాయి కదా దానికి.
No, is it like you want to reduce that pollution or you want to improve
We
the
can-
properties?
Properties of wood.
So then you should say it's improving the properties of wood rather than talking about the green thing, right?
Both are there, no, sir, if I use this.
Need not be.
Okay.
So, basically wood is like a composite, natural composite.
Yes.
So then why you are spoiling the structure of the composite material? Is there any reason like you are compressing it? So the bonding is gone, interlaminar strength will reduce. So why you want to compress it?
It will increase the strength, no, sir, if I compress at certain temperature.
Have you tested tensile
Yes.
for this?
Tensile, no, ఇంకా చేయలేదు సార్, చెయ్యాలి. It not over.
Then
We have to do.
unless you complete that, no, then we
Yes.
cannot comment on that one, whether it is improved. And what kind of heating mechanism? Can you go back to that heating mechanism?
This.
So is it like a direct heat or indirect?
Direct heat, sir. It is attached to the wood. We have ordered this one in some idea. GD Metla, we have ordered this one.
No, it is okay,
Yes, sir.
but the wood, whenever it is exposed to direct heat, there is a damage on the surface properties, right? So why you are applying the direct heat? Have you ever seen like
No, no, sir, not damaging this one. Damage a chance level because of this chemical composition. We have taken some area, no, sir. Particular area, that is a BS standards. Using some reference papers we have taken.
Okay.
So we have followed the BS standards. According to that, it is not damaging anything. Properties chances.
Why you are soaking it in water? Still, it's not clear.
It is
will
distilled
reduce
water,
the-
sir. Distilled water lo pettam. We have to remove the lignin, sir. We have to remove the lignin.
So where you are removing the lignin?
See, sir, there is a distilled water, no, sir.
Okay.
Lignin anta, after some time, the lignin is coming out. Lignin and hemicellulose. అందులో ఉన్న ప్రాపర్టీస్ ని బయటకు వచ్చేస్తాయి.
No, have you measured the weight or scientifically have you?
ఇంకా ఆ స్టేజ్ దాకా రావాలి. ఇది ఇనిషియల్ స్టేజ్. ఐ హావ్ టు టేక్ ద వెయిట్, స్పెసిఫిక్ వెయిట్స్ అన్ని చెక్ చేయాలి.
Then only you can comment that the entire lignin is removed, right?
I not experienced that one. After experiencing that one, I can answer this.
No, at least are you clear with which is matrix material, which is fiber material in this one? Oh,
No, sir, not check that one.
it's just like, see, lignin is acting as a matrix material. If you remove the matrix, only fibers will be there.
Yes.
Fibers cannot take the load and distribute among the fibers.
Hmm.
So I don't know why you
Sir,
are.
lignin is not completely removed. Not completely removed, sir. కంప్లీట్లీ తీయడానికి చాలా టైం పడుతుంది.
Many ambiguities are there. Maybe it is at the initial stages. All the best.
థ్యాంక్ యూ వెరీ మచ్.
Yes.
You said you're not removing it completely.
నాట్ కంప్లీట్లీ.
What is the percentage you want lignin to be in the material?
See,
You have to have some clarity on how much is the percentage of lignin you can accept as a non-property, right?
yes,
Yeah. What is that percentage?
actually in the take wood, percentage of lignin is 30%. Okay, which is more in the take wood compared to other trees. Okay, that is the main reason we are using the take wood in the doors or all those things. Okay, now here percentage ఎక్కువ ఉంది కాబట్టి మనకి టఫ్నెస్ ఎక్కువ వస్తుంది ఇక్కడ. అది ఎలా రిమూవ్ చేస్తుంటే ద ప్రాపర్టీస్ ఉంటుంది కదా, ఇట్ విల్ టేక్ 30 to 40 years టు గ్రో దిస్ వన్. సో ఆ 40 years 30 years లో ఇది హార్డ్నెస్ చాలా పెరిగిపోతుంది ఇక్కడ బికాస్ ఆఫ్
You
దిస్
did not
ప్రాపర్టీస్.
understand my question, sir. My question is, what is your purpose of removing lignin?
A porous material, there is a porous materials, no?
Yes. Yes.
So in that I have to implement again tungsten materials also.
So,
Andalo-
okay, you
andalo.
have some objective of
Yes.
removing lignin, right?
Yes,
And when sir has asked, it's an extension question actually. When sir has asked you, you said that partially you can accept lignin.
Mm.
To what percentage you can accept? Weight percentage should be there,
yes,
right? So to some what percentage you can accept lignin? Is it not disturbing? That percentage should not disturb the original properties of wood, right?
yes, yes.
So to what percentage I asked?
That I have to test, and orally I can't tell.
Okay.
Did you change any parameter?
No, not really.
Exact 100.
Exact.
What are the parameters changes in that at 100 degrees Celsius? Here, keep it in furnace at a continuous 24 hours or
Continuous 24 hours. Yes.
continuous 24 hours?
Yes.
What are the parameters are changing? If you're placing that, is there any damage or internal parameters should be changes?
Yes, cracks are there.
At what temperature the cracks are started?
Cracks are started. I don't know.
There is initial stage.
అది నేను చెప్పలేను ఇప్పుడు ఏ టెంపరేచర్ లో మారింది అనేసి.
One more thing, you are replacing the metal. And what purpose, particular application, in which case you have to be replaced that
we can make more hard than metal.
Okay, what particular applications, like in which application point of view you want to replace the metal? You have to use this wood.
That I can tell afterwards, not now. Thank you very much.
Thank you, sir. Thank you, sir. Next paper is by Dr. BP Madileti, sir, with paper ID 82, titled Thermal Performance Analysis of CFBC Boilers Using Python Tool. Sir.
Good morning, all. paper number it is 82. So my work is on thermal performance analysis. Thermal performance analysis using Python tool. Okay, so this is thermal performance of CFBC boiler. So CFBC boilers means circulating fluidized bed combustion boiler. So it has a specialized boiler it is. So it has a few advantages that compared to normal boiler, it can be operated for a wide range of fuels and at a low pressure and temperature also it can be operated. And compared to normal boiler, it gives less low emissions also. So that's why so nowadays right, mostly it is preferred. So here so I want to consider the different components of the CFBC boiler and using Python tool to analyze different uh, to evaluate the performance of the boiler. So the main objective of this right, to analyze the performance of CFBC boiler using Python tool. So here, first thing, specific goals are to implement a Python tool to get different information about the boiler. So to investigate flow rate characteristics and efficiency of the boiler and the combustion behavior. So here, so the main key parameters in the thermal performance are the boiler efficiency. So that is useful energy output. Okay, how much energy is heat energy is used and how much heat energy is supplied. So that is the main important thing. And the combustion efficiency and the heat transfer between different elements, heat exchange between the combustion gases and bed particles and the surrounding boiler surfaces. And the important performance factors here are air fuel ratio, bed material properties, and temperature distribution, flue gases recirculation. So here, so why a software tool is required for thermal for evaluating performance of the boiler? So here, the main reasons are the advanced modeling capabilities. So we can do using software and optimization can be obtained and most important right, industry standard. So here in the optimization potential they help optimize thermal efficiency, main important reduce the operating costs and maximum output can be obtained. The industry standards can be maintained. So some software tools here, examples, right? These are the few examples, Aspen Plus and XP, RI, Thermal Plus, FD, this is CFB CAD. These are the tools also used for evaluating thermal performance of the CFBC boiler. But particularly why Python here, I chose that. So Python is easy to use, open source and versatile. This is the open source, that is easy to use. And a strong support for scientific computing. There are many modules and libraries can be used in the Python. Powerful visualization tools like Matplot library. These things can be used, and it is very efficient for large scale simulations. Many persons, right, are working on this platform. So here the key Python libraries used here are the NumPy and the Matplot library, SciPy and Pandas. The Python Kinter graphical user interface. These are the different modules have been used in this. So what is the main methodology here? So obviously here first step is the collection of the input to data and data processing and modeling using basic equations, that is energy balance equation, combustion efficiency, these things, and obtaining the output parameters of the boilers at different operational conditions. So this is the main, right, entire what, this is the flow chart of this Python tool. So here it starts with by entering login details. It starts with, and here again it will here many for friendly usage. Many Python Kinter graphical user interfaces are used because for that helps to give the input to data easily, and we can modify the data. So here first of all, okay, right, it starts with the program, whether this boiler has the reheater facility or not. So first it will give that. So first we select whether that boiler has reheater facility. So once you give that option, whether reheater facility is used or not, then it will again create the graphical user interface that so once you select the reheater is present or not present, so it will run that input data operator, and it will starts, okay, right? It will display another user interface that will take the input data. So I will show that in detail. So again, okay, right, another graphical user interface. Okay, here we can do multiple things. We can load the data. We can modify data. We can modify the data and we can save it, and we can perform the analysis. Okay, perform the analysis, and we can produce the results here. And final graphical user interface. Okay, right, it will allows us that which kind of outputs. Okay, whether we need graphical representation data or okay numerical values, so correct output we need. Okay, we have the option here. So here graphical representation, okay, we can get the graphs also from this. So here entire flow chart, okay, I will show the okay, right, quickly tables how it will be. So it will start from here. So once you enter your information, then it will show that reheater is present or not. Okay, here once reheater is selected, okay, once you click on OK, here start button will appear. So once you start, okay, right, this button, okay, start the data. Here, this is very important for collection of input to data. That is very important for evaluating performance of the boiler. Okay. So here mainly data is divided into three categories. Okay. So now once in the table 1, so this is the data we can enter. So that is boiler input parameters like steam flow rate, feed water temperature, superheater outlet temperature, and reheater inlet pressure, ratio of steam mass reheater. These are the regarding all okay boiler input parameters we can enter here. Okay, so here we have the options. Suppose we have already Excel sheet with all the input parameters, we can load that Excel sheet directly here. Okay, or okay, many of the parameters remaining the same. So we need to change only 2 or 3 parameters. So we can enter here 2, 3. Okay, so we can save button is here. So once you click the save button, those 2 or 3 changes will be saved here. Okay, so until we can directly take the complete data from an Excel file, or you can want to change few modifications that can be done here. So once you can close it, you can go for table 2 data here. So once you go to table 2 data here, ultimate analysis, that is also called stoichiometric analysis, that needs other kind of input data. So what is the carbon, hydrogen, these the things are used here. So these stoichiometric entire data can be saved in the table number 2. Okay. So next you can give the input for table number 3 here. So that is for designing purpose. That is, suppose if you want to design the boiler, so for that, what is the fluid bed velocity? Okay, fluid bed temperature. Okay, those kind of input can be given the table. Just for our convenience, so that the data can be divided into 3 categories. Okay, it will be easy to us to look at these things. So once we are satisfied, once we are okay with this data, so we can okay, close it, and we can go to particular program and we can run. Otherwise, here results button is there. So by using that results button, we can go to okay, like this. So from that results button, so we reach here. So thermal analysis. So here, so these are the a few outputs.
Sorry for the disturbance, sir. We're having last 1 minute.
Okay. So heat duty, okay, flue gases, okay, right? These are the different data. And also we have the graphical representation. So suppose I want heat duty data. So here I will, when I click on the heat duty, I will show that what these are the values can be shown. Okay, here already I entered some few data for a particular boiler. So here we can get all the data here. Suppose I want flue gas data. So it will show that flue gas data here. And the next heat losses Okay, what are the heat losses taken by the particular gases? So if I want that data also, I can go for it. Next flow rates, these different. Which kind of data we want, we can get. Suppose I want graphical representation. I also go for here. So this, so what is that the mass here? Different gases or combustion elements. So which gas is playing the role? Okay, graphs also, from the graphs we can get that. So this graphical representation facility also is Python tool. Right here. So these are the okay, the Python tool. These are the steps, data input analysis steps. So what I did here after developing this Python tool, so I have taken okay, input data from the papers. So and I compared with that how this tool performing that. So but it is like okay, right here almost okay, right. This is the plant data blue color. This Python model color is mentioned here in orange. Okay, right. So here approximately okay, right, closely matching. Okay, this thing. So the results are closely matching, and this is for boiler efficiency. Boiler efficiency. Similarly, I plotted for actual data for real time plants, and this Python model I compared for fuel feed rates also. Okay, so those are also showing good agreement between values. And the heat duty values, and what is the heat duty taken by the economizer, evaporator, superheater, reheater, and those okay, right here. So here, okay, that we know that at low wattage power, okay, right. So few boilers will have reheater. So these two will not have the reheater facility. So but here, I compared economizer, evaporator, superheater. So this is the comparison between the Python tool evaluation and the real-time operating point. This is other three plants data for heat duty values. Okay, so for 5 plants, okay, right, nowhere there is a deviation much. There is no much deviation. Okay, right. In all 5 plants, data is matching very well. And this is for comparison of limestone feed rates for combustion. So here also, okay, right, different capacity plants, okay, right, compared here. So there, okay, it is obtained that good match between the this present Python tool performed well. So the conclusions are that, okay, right. So nowadays, okay, right, software tool requirement is okay there, because every time, okay, for construction, for design of the boiler, or for continuous monitoring of the boiler, okay, we need Python, okay, any software tools, but here Python has their own advantages. So it is showing the well agreement between the real time of plant values and this Python. So summary that this Python tool offers a powerful platform for analyzing the CFBC boiler performance. So thermal performance can be optimized through careful analysis and data-driven insights. In future, okay, right, still okay, right, we can use still integrate AI and machine learning also. So further we can improve this. Thank you.
Thank you, sir. Thank you for presentation.
Thank you, Mr. Mathileti. Nice presentation. Still, I could not understand from some of the graphs. There is a variation between actual data and your program data. These are all closed form solution. Like standard formulas are there. You will substitute the values and you will get the final parameter, right? So, but why there is a deviation?
These are planned to values. Those are not calculated by formulas. So those mentioned real-time data in the papers. Those whatever they're operating the boilers or how it happens. Those values given.
No, let me say heat duty percentage.
Yes.
5 divided by 100, something will be there. So I'll get the 5%. But that should not vary based on the, you didn't do any model. You just might have incorporated the formula in your program.
Here, yes, here model we have some kind of correlations and empirical formulas that incorporated in the Python tool. These values, okay, right, that those are not calculated by these formulas.
Then how did you calculate?
Python 2, we calculated, sir, for numerical.
And then what is that blue color one represent?
Color is the data that is obtained from the papers. Like this. Suppose actual data, that is actual data given there.
So the orange color one is the numerically calculated value, and blue color is it a measured value or blue color one? But both are calculated, there should not be any deviation. Both will be using like x is equals to a plus b means it should remain same. No. These parameters are generally a like closed form. As I said, y is equals to mx plus c. Similar kind of formulas will be there. So that is where there is a deviation is coming, right? Okay. Because these papers, they will not present all the data required for calculation. And another question is, this programming is a like very old technique. Means even when I studied, we used to do this. Now, the latest one is automation. Could have focused on automation, like real-time data collection and display it in the board or using the AI tools, you can analyze the data. That is much better compared to this one. These results do not show this way. These are not significant. Actually, they are supposed to match. Okay, thank you.
Thank you, sir. Thank you for your presentation.
Thank you, sir. The next paper is by Vishwanath Kumar sir and G. Janaki with paper ID 81 titled Investigating the Impact of Plastic Types on Fuel Oil Properties, an Experimental Approach, presented by Janaki.
Good afternoon, everyone. I'm G. Janaki from Chemical Engineering Department. Today, I'll be presenting about the investigating the impact of plastic types on fuel properties, and this is just an experimental approach. So, in this experiment, we have conducted the experiment on types of plastics which can be turned into fuels using a method called thermal pyrolysis. So, our aim is to reduce the plastic pollution and use the product obtained in a sustainable way that can be help to the environment. There are two methods to convert the plastic into fuel: gasification and pyrolysis. In the pyrolysis, we have another two methods: catalytic pyrolysis and thermal pyrolysis. So we have opted thermal pyrolysis to conduct this experiment. So promoting the pyrolysis for production of sustainable fuel. By using the mechanism based process, thermal pyrolysis, we have converted the plastics into a fuel. There are different types of plastics such as LDPE, HDPE, PET, PVC, polypropylene, etc. So we have conducted the experiment using LDPE, HDPE, PET, and polypropylene materials. So this is our experimental work. First, we have taken 100 grams of plastic raw materials, and then using a reactor, we have converted, like we have heated the plastic materials at the temperature of 300 to 500 degrees Celsius. Then using a condenser, we have cooled the gases obtained at the temperature 20 degrees. Then we have obtained a fuel of 11.5 to 12 milliliters. Uh, First, initially, we have taken the plastics of each type. As I mentioned, HDPE, LDPE, polypropylene, and PET materials. We have taken each of 100 grams. Then we have introduced the materials into the reactor. In the reactor, we have a heating coil, a cylindrical shaped heating coil. Using the coil, we have introduced the heat into the reactor, and the reactor is surrounded by a hard material so that there is no heat loss or gases loss. Uh, the raw materials which are introduced into the reactor melts the material, and it and a gas is produced from the melting. Then the gases are collected in a condenser. A condenser is attached to the reactor, and it is also outlet is produced. Uh, so this is the setup of our experiment. You can see that a condenser is attached to the reactor, and the outlet is collected in a beaker. In the reactor, after the melting of raw materials, a gas is produced from the reactor. It is then passed through the condenser using a U-bend, L-bend, sorry. Then we have used water as a medium for cooling. So then the water is circulated inside the condenser, and it helps in cooling the gases produced. The temperature we have set is around 20 degrees. And then the cooled gases can be collected in, the cooled gases forms into a fuel oil. Then the fuel oil is collected in a beaker. Then like we have obtained around 11.5 to 12 milliliters of oil. This is the general methodology of pyrolysis. First, a feedstock is introduced, and then the pre-processing where the moisture or any unwanted materials are removed. Then the material is introduced into the pyrolysis reactor. From the pyrolysis reactor, we can obtain three types of byproducts. Syngas, bio-oil, and solid residue. If any inorganic materials are obtained, they can be removed in the pre-processing state. Then from the pyrolysis reactor, the produced syngas and bio-oil is used for transportation fuel, and the solid residues such as carbon black or char can be used for other purposes. Then this is the schematic diagram for the thermal pyrolysis process. These are the characteristics of the raw materials we have chosen. We have taken plastic bottles, plastic bags, disposable cups, and plastic cups. Then coming to the results, we have choose the three methods for we have choose the three types of methods to declare our results, such as high heating value, kinematic viscosity, and density of the properties. Comparative to diesel oil, which we generally use, this obtained oil can be used as an alternative fuel for the diesel. When we compare the high heating value with the diesel, we can say that polypropylene matches the range of diesel fuel, because for the diesel we have high heating value around 45 megajoules per kg. So, and we got the polypropylene properties as around 44 megajoules per kg. And then kinematic viscosity. For the diesel, we have kinematic viscosity around 4.5 centistokes. So for polypropylene, we have around 4.4 to 4.5 centistokes. Then density of diesel is around 800 kg per meter cube. Then we got polypropylene density is around 770 kg per meter cube. So analyzing all these properties, we can say that uh, polypropylene can be used as an alternative fuel for diesel. So this is the analysis data for different plastic materials we have taken. The weight is same for each material. Then the amount of oil we have extracted. The temperature ranges are generally from 300 to 500 degrees Celsius. Coolant temperature is constantly maintained around 20 degrees. Then the runtime is around 100 to 130 minutes. In the conclusion, we can conclude by the analysis we have obtained that polypropylene among the other raw materials such as PVC, PET, HDPE, LDPE, and etc. Polypropylene has the feasible range and affordable financial conditions which can be used as an alternative fuel for the diesel oil. These are the references we have used. Thank you.
Thank you, Ma. Thank you for presentation.
Thank you. Maybe I don't have background of chemical. Still, I can give some basic questions I can ask. Pyrolysis you have done. So how do you maintain the temperature of 20 degrees?
So 20 degrees, we have used water as a coolant, sir. So we have measured.
How you are sure that it is at 20 degrees?
We have measured it using thermometers.
Okay. And calorific value, what is the calorific value? Have you measured the calorific value? How do you decide a fuel?
Sir,
If this is a good, like let me say
Yeah.
coal, petrol, diesel, like how do you decide which is better?
so for coal, we use a high calorific value and
So
we decide.
whatever output you are getting, have you measured the calorific value?
No, sir, we have only choose this high heating value, kinematic viscosity, and density properties.
No, you are directly proposing you can replace the diesel.
Yes, sir.
right?
Like
Then
using these methods, then it is applicable.
it's a very old technique. Pyrolysis, I remember it's there since long time, right?
Yes, sir.
Now, coming to the glass transition temperature, what is the TG of all these four materials? Do you know?
Yes, sir.
And what temperature you have heated them?
Around 300 to 500 degrees Celsius, sir, we have
Which is
maintained.
much more, much above the TG of all materials. You are aware about TG, right?
Yes, sir, glass.
So then once you are heating at that particular temperature, oh no. Have you tested calorific value of, or at least the raw materials?
Yes.
Thank you.
Thank you, sir.
What is your name? Go back to the first slide.
I'm Janaki, sir. Goldapalli. I'm Janaki.
That I am pronouncing it. A is missing.
Oh, sorry. Yes, sir. Thank you, sir.
Thank you, Janaki. And now we have an online presentation by Mr. T. Hariprasad, sir, with paper ID 61, titled Performance and Emission Characteristics of Waste Fish Oil with Dimethyl Carbonate as an Additive.
Good afternoon, sir.
My voice is clear. Sir, my voice is clear. Good afternoon.
Sir, good afternoon, sir. Hariprasad, sir.
Yeah, my voice is clear, ma. My voice is clear. Hello. My voice is clear.
Sir, are you hearing me, sir?
This is clear. Hello. Sir, my voice is clear. My voice is clear. Hello. కృష్ణ వాయిస్ వినపడతానా? అది ఏమైంది? సెట్టింగ్స్ ఏం పెట్టుకోవాలా? ఆడియో ఏమైనా ఐడియా ఉందా? ఓకే, సెట్టింగ్స్ మార్చుకోవాలా ఏమన్నా? ఓకే. Hello.
Sir, are you hearing me, sir?
My voice is clear again, sir.
We are not hearing you, sir.
Now, sir?
Yeah, now it is fine, sir. We are hearing you.
Okay.
Sir, now you can start your presentation, sir.
Okay. Shall I proceed?
Yes.
Yeah. Sorry for the inconvenience. This is a paper of my student actually. Since he admitted in the hospital, I am not able to present PPT. So sorry for that. The title of the paper is The Performance and Emission Characteristics of Waste Fish Oil as a Biodiesel combined with dimethyl ether carbonate. So here now, why I have selected a waste fish oil as a biodiesel means for source resource as a biodiesel means fish oil. No, India is having a very much coastal line, so there is a plenty of availability of resources for waste fish oil will be available. So that waste fish oil is waste fish products are collected and converted into fish oil. Later on, with the transesterification process, we converted fish oil into biodiesel. Since with the use of biodiesel, no, there is a because biodiesel contains less calorific value. So since it is having less calorific value, we added since this less calorific value causes the decrease in the break thermal efficiency. That's why we have selected one oxygenate component, that is carbonate as an additive, dimethyl carbonate as an additive, so that to improve the efficiency and to reduce the emissions. Now further, we added this dimethyl carbonate in the investigation. So this is a work done by Mr. Lakshmipati, working as a assistant professor now. Sri Venkataperumal Engineering College. Now he is pursuing his PhD recently in MB University. Okay. Go to the next this thing. Go to the biodiesel. No, here now we selected. This fish oil is a biodiesel. You move on. No? You move on. We selected fish oil as a biodiesel, and with the transesterification setup, now we converted this fish oil into biodiesel. So the standard process is transesterification process is there. So with the help of that, we collected oil and we heated up to certain temperature around 70, and we stirred and we added catalyst and all those things. So later on, we kept that solution for 24 hours. No, then separation of the glycerin and biodiesel is happened. The biodiesel. One second, sir. 1 second. So later on the biodiesel is now taken and separated from the glycerin, and the biodiesel is heated up to 100 degrees centigrade, around 100 degrees centigrade, so that any moisture present that will be heated. Later on, that biodiesel is taken and it is mixed with the dimethyl carbonate with the different proportions, and we made different blends like B10, B20, like blends we made with the diesel, biodiesel and dimethyl carbonate, and we tested in the single cylinder diesel engine. And we go to the next page. We examined the performance of the diesel engine with these fuels, these things as a fuels. Okay, so when you test generally diesel is having better performance, more break thermal efficiency. So when you go for this biodiesel, what will happen? There is a small decrease in the efficiency, due to low calorific value and all this. In order to compensate the decrease in efficiency, what we did is we added this dimethyl ether carbonate will be added to these things. So what we observed in the experimentation is when we try to add this biodiesel and dimethyl ether, there is a decrease in efficiency and increase in NOx emissions. So when you go for this combination, there is an increase in NOx emissions and decrease in SC emissions. So if you want to decrease the emissions, there is once again compromise between the break thermal efficiency and emissions is required. That's why we selected the best blend for the examination. Go to the results section. Please. So this is the description theory about the various emissions which come across in the diesel engine. So this is the fish oil which is fabricated in the experimentation by using transesterification process. So this is the engine setup we have used for experimentation, single cylinder diesel engine. That is the experimental Kirloskar diesel single cylinder engine we have used for the experimentation. These are the specifications of the engine. 3.5 kilowatt, that means 5 HP engine only, single cylinder water cooled engine only. These are the dimensions of the engine, like a bore and stroke, everything is mentioned here. And experimental procedure, procedure is, so we have taken fish oil and we have taken that oxygenated compound D, that is, we made into different blends like B10, B15, B20, all these things will be there. Next thing is okay, calorific value, bomb calorimeter will be there. Is it for testing the calorific value? Properties will be, we obtained various properties of the fuels we have used in the experimentation, like flash point, fire point, density, and all those things, viscosity. All these things will be listed in the table 2.1. So if you see here, the values will be there. The properties now, like if you see calorific value, the calorific value will be goes on decreasing. So diesel will be having around 44,000 now, whereas B10, B15, B20 will be calorific value will be for biodiesel, it is decreasing since we added this this oxygenate compound. There is a slight increase in the calorific value for other fuels. So similarly, flash and fire point is increased, and C10 number also, that is the advantage of going for biodiesel. C10 number is increased to 51, 58 and 51, all these things will be there. So if you see the results and discussions, performance curves of the fish oil will be there. So here, if you see diesel is having more efficiency when compared with the other blends. So here, since calorific value is very less, that is the reason why it is decreasing when compared to diesel. In order to improve the efficiency, it is suggested to go for the oxygenated compound like D-methyl carbonate. So that whatever the loss is happening with the less calorific value, we can compensate certain extent so that we will gain in the brake thermal efficiency of the fuel. So that is a thing which is happening with respect to the performance of the brake thermal efficiency of the diesel engine. Next slide. This is a brake specific fuel consumption. So with the addition of this biodiesel, there is a slight increase in the brake specific fuel consumption because it is inversely proportional to brake thermal efficiency. So just like brake thermal efficiency, it is inversely proportional to the brake thermal efficiency. Okay. Next, emissions. Coming to the emissions, HC emissions will be drastically reduced with the addition of biodiesel as well as this oxygenate compounds, because biodiesel also contains oxygen and as well as this oxygenate compound also will have more amount of oxygen. Therefore, the HC emissions will be greatly reduced by the combination of all these things. Go to the next one, HC. Next, CO emissions will be there. When you go to the CO emissions, so CO emissions will be just similar to that of HC emissions only, because since oxygen is present more, since it leads to better combustion of the fuel, that leads to complete combustion of the carbon. So, therefore, the CO percentage will be, the trend will be goes on reducing, and with respect to brake power also, all the emissions will be goes on increasing, because high amount of brake power takes a high amount of fuel. When a high amount of fuel is there, a high amount of biodiesel and a high amount of oxygenate compounds will be there. So that's why the trend will be with respect to brake power, CO emissions will be goes on increasing, and with the addition of biodiesel and this agents, oxygenate agents, the efficient and the CO emissions will be goes on decreasing. That is the trend we are observing here. Next one is NOx emissions. So the disadvantage of using biodiesel and oxygenate compounds will be with respect to brake power. So at higher temperatures, nitrogen have a tendency to react with oxygen and forms nitrogen oxides. So therefore, biodiesel will be causing, since it is having a high amount of oxygen, it causes high temperatures. That's why if you see the emissions, the NOx emissions will be goes on increasing with respect to biodiesel as well as with respect to this oxygenate compounds. Okay. Next one is performance of the characteristics of the biodiesel with the blends of we have taken the blend 15 with D-methyl carbonate. So why we have considered D-methyl carbonate means the drop in efficiency will be happening. So in order to improve that efficiency, we added this dimethyl carbonate with certain percentage. That is 20 ppm is there, 40 ppm is there, and 60 ppm oxygenate compounds will be there. So the here also the efficiency is slightly increased when compared with the biodiesel with the diesel when compared with these fuels. The B15 blend with all these things. Now there is a slight increase in the brake thermal efficiency is happening. Next. Similar case with the brake specific combination. Whenever brake thermal efficiency is increasing, the brake specific combination will be decreasing because it is inversely proportional. Coming to the emission characteristics of the fuel, no, so when compared with the diesel, no, the when you go with the blend 50 with the different concentrations of oxygenate compound, no, the HC emissions will be further reduced. That clearly shows in the bar diagram the decrease in the HC emissions. Next one, CO emissions. No? Similar trend is observed with the CO emissions also. You go to the CO emissions. CO emissions also will similar trend because the presence of more amount of oxygen in the biodiesel as well as oxygenate compounds with different concentrations.
Hello,
The
sir.
CO emissions will be further get reduced. That is
Sorry for the disturbance, sir. You are having only 1 minute, sir.
Okay.
Last 1 minute I have to complete, sir.
Pardon?
So you are having 1 minute time, sir, further.
Okay. Go to the nitrogen emissions. Here nitrogen emissions now, with respect to temperature, the emissions will be goes on increasing because at high temperatures nitrogen will react with the oxygen and forms nitrogen oxides. So here now that oxygenate compounds as well as biodiesel will be causing a more amount of temperature in the engine cylinder. That's why it leads to here with respect to concentration as well as with respect to brake power also, these emissions will be goes on increasing. That is a disadvantage of going for biodiesel as well as oxygenate compounds like dimethyl carbonate. Okay, next one, last one. So this is about the conclusions. So when you go for a biodiesel blend, no, the efficiency will be goes on increasing and it is causing a reduction in the HC emissions, CO emissions, and there is a chance of increasing NOx emissions. Therefore, we have taken a dimethyl carbonate as a oxygenate compound to compensate the loss of efficiency in the presence of dimethyl, in the presence of biodiesel. So once again, we cannot we cannot go with the diesel, or we cannot go with biodiesel. Therefore, biodiesel and dimethyl carbonate. So there is a trade-off between all these things to get the more amount of to optimize the parameters. We need to go for a trade-off between these two parameters. The best combustion we suggested will be when a B15 with dimethyl carbonate will be having a better performance. So that is my conclusion. So thank you for giving this opportunity to present my paper. Any questions, you can welcome.
Thank you, sir. Thank you for your presentation.
Okay.
Please discuss with the session chair, sir.
Sure.
Hello, thank you. Thank you for the presentation. So, why the fish oil? The methanol is so popular, and also they want to implement in the petrol bunks also, right? Blending of methanol. So, why did you choose fish oil?
No, actually, no. Fish oil will be waste fish oil we collect. We have that is because India is having very coastal area is very high, sir. Their waste products of fish will be plentifully available. That will be easily converted into oil and they can be recycled to biodiesel. So that is the reason why we have considered one of the resources will be for it is available throughout the year and it is renewable also. We can have much resource will be available to high coastal areas in India. That is the reason we can chosen one of the resource will be for fuel as a fish oil, waste fish oil, not.
So, have you checked any consistency of availability of this fish oil? Like calorific value, will it remain same or from different sources?
Definitely, sir. Calorific value when compared, definitely it will be varies from. That is depends upon the quality of the fuel we selected, sir. It will be varies from nature of the quality, nature of the fuel nature of the source also, sir. But the difference may not be that much, but it will be less than I think fish oil only, sir. Diesel it will be always less than diesel only. So for this case also, similar.
So what is the flash point for both of them, diesel and have you compared that?
Yes, sir, it is there shown in the table. So flash point will be generally, it will be high for biodiesel. So when compared with the diesel, around go to the table,
Okay.
properties table. Generally, it will be more. So.
Okay. Nice work. Thank you.
Sir. Thank you for giving this opportunity, sir. Thank you.
Sir, thank you, sir.
Thank you.
Sir, 1 minute, sir. Questions from audience. Let me.
Okay.
Sir.
So what's the process you are using for the filtration purpose, sir? Is there any stages how can filter? If you want to make a 1 liter of oil, so how much quantity of fish should be required to convert it?
Okay. So generally now we have taken the process we have used will be transesterification process. Trans-esterification process. That is a best method people will be using for converting any oil into biodiesel. So generally, no, if you take fish oil around half liter, call liter or something like that, you will get the yield will be around 80% will be there. 80% to 90% will be yield will be there with methanol and KOH other ingredients. You will get around 88% will be there. So if you take 1 liter means hardly you will get around 88 ml fish oil will be you will getting. Biodiesel will be you will getting from the fish oil that will be there.
So directly you can use it or any filtration process stages in that?
No, actually, transesterification process filtration is always required, no?
Yes, yes,
Because it will contain so much of these things will be there. But whenever in the market, you will get a ready-made oil, fish oil. If you do, no, means we need filtration and all these things. But market, fish oil will be readily available. That's why we converted directly. We have not used any filters and all those things. But without filter, if you directly use means raw oil, it will be causing so much of inconvenience in the engine cylinder, and finally it means the damage of the vehicle, even engine cylinder also will happen. Filtration is always required with the fine filters.
The mechanical efficiency.
So mechanical efficiency will be greatly reduced with small the 3 to 4% will be reduced due to low traffic value. That will be compensated with the other additives like one of the technology we are using will be this kind of oxygenated compounds we can use. We can further compensate the loss with the addition of this kind of oxygenated agents actually.
Thank you, sir. Thank you for presentation and
yeah. So
nice to see you, sir, after a long time.
Yeah. Actually, this is my student work. So he is not completed that PPT and all this. I'm sorry for the inconvenience I made.
No problem. So myself and Madhuleti both are working at Andhra University, sir.
Okay, Madhuleti also working there.
Yes, sir.
Great. Thank you. It's very nice to hear both of you working there. And
sir, one more professor.
Okay.
Sir, good afternoon. I am Chalpati, the head of the department here.
Sir. Good afternoon.
Just now, Professor Vasu sir joined us from
Sir.
NIT Warangal.
Sir, Vasu sir, I know very well, sir, because he's a friend of our HOD, Satyam Meher. And I met through online, sir, many times and phone call also. Sir, Vasu sir, good afternoon, sir.
Good afternoon. Yeah. How are you?
How are you, sir?
Fine. Okay. Yeah.
Nice meeting you, sir, after a long time.
Nice, sir. The presentation is good. Okay, sir. Thank you.
Thank you, sir. Thank you.
Nice.
Sir.
You can leave, sir, now.
Now I invite Mr. Harish Mugudka, sir, to present his paper on experimental design to identify the optimal drilling parameters of MWCNT's reinforced GFRP composites.
Good afternoon, sir. Myself, Harish. Today I will be presenting my paper on experimental design to identify the optimal drilling parameters of multi-wall carbon nanotubes reinforced with glass fiber reinforced polymer composites. So in the work, I have the work is to optimize the drilling parameters of MW CNT reinforced glass fiber reinforced polymer composite utilizing the modified Taguchi approach. So in this approach, in this work, I have considered weight percentage of the carbon nanotubes, speed and feed rate as the process parameters, and thrust force and delamination factor as the performance characteristics. And during the experiments, I have utilized the L9 orthogonal array for the work to minimize the thrust force and the delamination factor, and the optimal process parameters has been identified. So the fiber composites are mainly used for the applications of automobile, industrial applications like automobile, marine, aerospace, construction, and renewable energy. With the addition of the nanoparticles, its specific strength and stiffness will be improved, and corrosion resistance will be improved, and it will become lightweight with the low thermal conductivity. So I have focused on the machining. So this is the stepwise procedure how the laminate has been prepared. First, it is the nanoparticles is mixed with the acetone to dissolve the carbon nanotubes, and the epoxy has been added to it. Further, to remove the acetone, it is placed in a vacuum oven, and then the mixture is added with the hardener, and further the laminate is produced through vacuum assisted resin transfer molding. The laminates, once the laminate has been formed, it is cutted in 100 mm by 80 mm with a thickness of 7 mm. Around 8 layers of the glass fibers has been placed at an orientation of 0 and 90 degrees. So in the work, once the laminate is formed, it is drilled. The drilling parameters are the MWCNT composition, cutting speed, feed rate. With the Taguchi method, orthogonal array, the drilling operation has been done. During the drilling operation, machining operation, the thrust force is calculated. After completing the experiment, the delamination factor has been determined. So delamination is the damage occurred on the hole. So which is the numerical value which is determined by Dmax, that is maximum diameter by tool diameter. Here in this 8 mm tool diameter is been used with the HSS material. So as I have used the 3 process parameters, MWCNT content, cutting speed, and feed rate in a range of 0 to 1 weight percentage, 25 to 75 meter per minute, and 0.1 to 0.2 mm per revolution. So in the modified Taguchi approach, the total for nine experiments with 3 levels, 4 parameters we need to get. So to introduce the 4th parameter, a imaginary parameter has been introduced, that is fictitious parameter at 3 different levels. So it is just an imaginary parameter. So with these parameters, the experiment has been conducted and the output characteristics has been noted for L9 array. Now, this is for the 4 parameters, including the fictitious parameter. Further, the ANOVA has been determined. So in this ANOVA, the maximum contribution for thrust force is with the feed rate of around 85.7%. And whereas for the delamination factor, the carbon nanotubes content is contributed more with the 63.7%. Now using additive law, I have determined or predicted the values for 3 parameters. Once the 3 parameters has been determined, it is listed with the 3 parameters, that is NP is equal to 3 and NP is equal to 4. So with these values, I have determined the relative error for the output responses for the thrust force and the delamination factor. And the expected range is determined so that the obtained values lies within the minimum and maximum expected range. So as I have conducted the experiment for 9 experiments, a full factorial design has been determined with the additive law, and it is observed that for both the responses, the test data lies within the expected range, that is lower limit and upper limit. And with the ANOVA table, from the ANOVA table, the empirical relations has been developed. So these are the empirical relations. Once the empirical relations has been developed, with these empirical relation, the test data, with these empirical relation, it should lie between the upper bound and lower bound. That is, the graph represents the estimate of the output responses from the empirical relations. Next, as to determine the best optimal solution, the minimization of the minimization of the output responses has been done. For single objective function, the best optimal solution was found to be at MW CNT content at third level, and cutting speed at third level, and feed rate at first level. This is for minimum thrust force and minimum delamination factor. The parameters are A3, B1, C1. As I need for multi-objective, as my objective is to minimize both the output responses, the weight factor is taken as 1 and 0.5 and 0.5, and I have determined the value of the optimal solution. I have determined the optimal process parameter at A3, B3, and C1. So at these parameters, the experimental values are thrust force at 54.1 Newton and delamination factor of 1.108, again, which is lying within the range of the expected values. So coming to the conclusion, the optimal solution for minimal thrust force and the delamination factor was found to be at a speed of 75 meter per minute, feed rate of 0.1 mm per revolution, and 1% of MWCNT content. So these are a few of the references. Thank you.
Thank you, Harish. Thank you for your presentation.
Thank you, Mr. Harish. Nice presentation. So what is your objective? I'm not clear. You want to improve the drilling performance, or what is it?
Yes, by minimizing the thrust force and the delamination factor.
So how nanoparticles are affecting that?
It is not for the composite material. I have performed the process, sir. I have made the laminate with those by adding the carbon nanotubes and glass fiber.
No, why you are adding? That's my basic.
So actually, it is the machining part is the second part. In first part, I have checked with the mechanical behavior also, sir.
Okay. So then why you are doing the drilling? Any specific?
No, we can perform any of the machining operation for any particular application. I have selected the drilling as one of the machining process.
No. Would you like to show that this is improving, or what is your objective?
So through drilling, with this approach, the optimal process parameter has been identified. That's it.
Using
No.
nanoparticle, you want to show that the machining is improved?
Mechanical performance has been improved, sir.
That's
that is the other part of the work. So with the extension for that improved mechanical properties of the composite fiber composite, I have used the machinings.
So using machining, what do you want to prove? That's okay. Drilling you have done. So what do you want to prove? Delamination is reduced?
Yes, delamination is reduced.
Reduced.
Yes, sir.
And thrust force, is it significant? Like variation will be like 10% or something.
Yes,
How
sir.
it is going to influence? What is the significance of thrust?
It may depend upon the orientation of the fibers lying On that also the thrust force may depend.
No, why it is important? Why you want to reduce it?
It will be damaging the hole, sir.
Okay. The stronger the material, it will give more thrust force.
Yes.
Then. Okay. Thank you.
Thank you, Harish. Any questions from participants? Okay, thank you.
As we conclude the session, we would like to express heartfelt gratitude to all participants and session chairs for their invaluable contribution to the conference. To honor the contributions of Professor Fanindra Kiran Chaganti Garu, I now invite Dr. K. Srinivas Jalpati Sir, General Chair, ICIFMEDE, Dr. Sikindar Baba Sir, Convener, Dr. Krishnaya Sir, Co-Convener, Dr. Madan Mohan Reddy Sir onto the dais. Sir, please come onto the dais. I request Dr. Vasu Sir to join the felicitation. Thank you, sir. Now I request all the participants and faculty to attend the lunch break at D Block Canteen. And please get back here for the further sessions by 2:15.
In the afternoon, we'll start with the keynote session by Professor Vasu sir, Professor of Mechanical Engineering from NIT Warangal, and it will start sharp by 2:15. So